Hello guys, today we are solving differential equations using power series. So I will start with example and then we get more understanding of this topic. So the question is, find the general solution of y prime prime minus x multiplied by y equal to 0 using the power series as a solution. But before that, let's look at how to take derivative of a power series. So when you have a power series, so this is our power series with the index starting from 0 to infinity. So when you take the derivative of a power series, that's y prime, it will give us a summation from our index from 1 to infinity. Then this is this is a constant, and this is our variable that we are working on. So the exponent of the variable used to multiply the series, and then we subtract 1 from it. So when you use this to multiply the series, we subtract 1 from it. So when you take the second derivative, what we are going to do is that this is the first derivative, so we are going to use the exponent to multiply the series, and then we subtract 1 from it. It's the same thing that we will do for when you take the third derivative. So what you are going to do is that it will start from n equal to 3. The second derivative started with 2. The first one 1, and then the initial 0. So we are taking the fourth order. It will start from the index will start from n equal to 4. So the same thing that we are going to do here, we are going to use the exponent of s to multiply the series. Are you okay? So our n minus n minus 1 into bracket, then to bracket n minus 2 multiplied by x, and so when you subtract 1 from it, we are getting negative 3. Are you guys okay? So we are going to use that idea in solving the question. So let's proceed to solve our question. So we have our power series here, and this is the question that is given to us. So what we are going to do is that we just take that means we are going to take the second derivative of the power series, and then we substitute, and then we take the initial power series, also we substitute, then we create it to 0. That's what we did here. Are we okay? So the second procedure, what we are going to do is that we are going to simplify. Looking at this, we have x here, and then we have x term here. So when we multiply this x by x minus n, it will give us x raised to the power n plus 1. Are you guys okay? So we still maintain this. Now what we are going to do is that, looking at the generic term here, is x raised to the power n plus 1, and then here is x raised to the power n minus 1. This one is negative and this one is positive. So what we are going to do is that we are going to make sure our generic terms are equal. So this is positive and this is negative, so we make sure that this is equal to this. Are we okay? So we have negative 2 here, so we add 3, we get plus 1, which will be equal to the power series here. So we have to add 3. When we add 3, we add 3 in the series, and then we subtract 3 in the index. Are you okay? So that means to become 2 minus 3, and then we add 3, and then we add 3, and then we add 3. So we still maintain this power series here. Are we okay? So when we simplify this, we are getting this. Looking at this, our indices are now equal. Are we okay? Our indices are now equal. So we are now going to focus on the our generic terms are now equal. So we are going to focus now on the indices. This one is from n equal to 0, and this one is from n equal to negative 1. So now here our initial term is at negative 1, and then here is our initial term. Here is what is at what n equal to 0. So we can move from -1 to what 0. So what we are going to do is that we are going to what extract our first term from this series, from this power series. Are we okay? So what we are going to do is that we are going to substitute -1 into the series. So when we substitute -1 into the series, that means wherever we see n, we substitute what, we replace the n with what, -1, and we still maintain our what power series here. So we are extracting our first term, which is at n equal to -1. So when we extract our first term, our second term will now start from 0. Are we okay? Our second term will now start from 0 to infinity. So when we simplify this, our first term here, we are getting 2 multiplied by a subscript 2. Are we okay? This -1. So when you substitute -1 here to become 0, any number raised to the power 0 is what, 1. So this becomes 1, and then our value becomes 2 multiplied by what, a2. Then from here, our index will now start from 0 and then 0. So what we can do is that we can simplify this. Are you okay? These are 2 power series whose indices start with what, n equal to 0 and n equal to 0, and their generic term are what, the same. So we can simplify or factorize. We can factorize. Are we okay? So when we factorize this, we are getting this. Are you okay? So we are going to factorize our summation sign outside, our generic term outside. So this is here, and then our constant is also here. So having this, what we are going to do is that we are going to equate this to the other side. We have equal to what, 0 here. So we have 2a equal to what, 0. That means our a2 is equal to what, 0. Are we okay? So we equate this to 0. Are you okay? So when we equate this to 0, we have this minus an subscript n equal to 0. So we can group like terms, then we factorize. So when we send negative an to the other side to become positive, then we divide by n plus 3 into bracket, another bracket, n plus or 2. Are we okay? So we are getting these 2 equation. Are you okay? So what we are going to do next is, we now know our a2 to be 0, and then our an plus 3 to be this. So we are going to find the other terms. Are you okay? So that means we can let our n to be start from what, 0, 1, 2, 3, 4. Are we okay? Looking at this, our n is what, starting from 0 to what, infinity. So our n will start from 0 to infinity. So we have one of our equation to be this. Are you okay? One of our equation to be this. So we are going to find the rest of the terms of the series. Are you okay? Now if we let n to be 0, that means we are going to substitute 0 into this equation. So in substitute 0 here, it will become a subscript 3, and this will become a naught, and then when you substitute 0, 0, it will become 3 multiplied by 2. So we are getting a naught all over our 3.2. That means 3 multiplied by what, 2. So when we let n to be 1, we are getting this. So we will just be substituting the numbers into this equation. Are you okay? So looking at our n equal to 2, when you substitute 2 here to become 5, and this will become 2. Substituting 2 here, 2 here, 2 here. So it will become 5 multiplied by 4. But we know our n2 to be 0. Are you okay? We know our n2. From here we know our n2 to be 0. So that means you substitute 0 here, and it will make the whole of this equation to be what? 0. So our a5 is 0. So the same idea for n equal to 3, and n equal to 4, n equal to 5, n equal to 6, up to infinity. Are you okay? So when you find your terms, so these are our terms. So this is what you are going to do to find what? Your terms. So from that you expand what? The power series. This is the expansion of the power series. Are you okay? To infinity. You know, power series is what? A continuous function. So this was our power series. So what you are going to do is that you are just going to substitute the values here into the series. Are you okay? Just going to substitute these values into what? The series. So you have our a naught. We know our a naught is what? Unknown, and then our a subscript 1 is also unknown. So this will be this, and then we have our a2 to be 0, and then we have our a4 to be this. So you are just going to substitute this into the equation. So we are getting this. When you substitute this into the equation, we are getting this. So now, looking at the series, you can see that we can see a naught here, a1 here, a naught here, a1 here, a naught here, a1 here throughout the series. Are you okay? So what we are going to do is that we are just going to what? Group like terms, and then we simplify. Are you okay? So grouping like terms, we will get what? Our y of x to be this. So when you do this, you group like terms, you are going to get this equation. This is what you are going to get. So this becomes our solution to the question. Are you guys okay?